Hello everyone, welcome to VLSI Gold Chips. Let's continue Verilog Interview Questions. How to avoid unintentional latches in the design? And the solution is completely specify all branches for every case and if statement. Completely specify all outputs for every case and if statement. Use synopsis full case if all desired cases have specified. Next question is, what is a full case statement? A full case statement is a case statement in which all possible case expression binary patterns can be matched to a case item or to a case default. If case statement does not include a case default, and if it is possible to find a binary case expression that does not match any of the defined case items, the case statement is not full. What is a parallel case statement? A parallel case statement is a statement in which it is only possible to match a case expression to one and only one case item. If it is possible to find a case expression that would match more than one case item, the matching case items are called overlapping case items, and the case statement is not parallel. Pros and cons of latch and flip-flop. Latch takes less area, consume less power, facilitate time borrowing or cycle stealing. Not friendly with DFT tools. So here you can see the latch implementation. Always at the rate of clock, begin. If clock is equal to 1 single apostrophe B1, Q less than equal to D. End. So we implement latch. Flip-flop takes more area, consumes more power, allows synchronous logic, friendly with DFT tools. So you can see the code for D flip-flop. Always at the rate of passage of clock, begin. If reset, Q less than equal to 1 single apostrophe B0, else Q less than equal to D. End. So this is how we try to implement the flip-flop. Write a Verilog code for D flip-flop with the synchronous reset. You can see the code for D flip-flop with synchronous reset. Write Q always at the rate of passage of clock. If reset, that means if reset is 1, Q will be equal to 0, else Q will be equal to D. So it is synchronous with respect to the clock. So the reset is synchronous with respect to the clock. Write a Verilog code for D flip-flop with asynchronous reset. So here you can see D flip-flop with asynchronous reset, RHQ, always at the rate of passage of clock or passage of reset. So here, if reset is 1, then it will enter into this always statement. If reset is 1, Q less than equal to 1 singular post B0, else Q less than equal to D. That means, so here passage of clock and passage of reset have been used as sensitivity list. If there is a rising edge of clock or rising edge of reset, then it will enter into this always statement. So now we can implement asynchronous reset for D flip-flop. Write a Verilog code for D flip-flop with the gated clock. Here is a code. RHQ wire GTD underscore CLK, that is equal to enable double ampersand clock. Always at the rate of passage of GTD underscore clock, then Q less than equal to D. So here we are using gated clock. Enable and clock has been added, that is assigned to gated clock, and that will be used as the clock for this flip-flop. Next question. What are the guidelines for coding priority encoders? Non-parallel case statements in for priority encoders. It is a poor coding practice to code priority encoders using case statements. It is better to code priority encoders using if-else if statements. Code all intentional priority encoders using if-else if statements. It is easier for a typical design engineer to recognize a priority encoder when it is coded as an if-else if statement. Case statements can be used to create tabular coded parallel logic. Coding with case statements is recommended when a truth table-like structure makes the Verilog code more concise and readable. Examine all synthesis tools case statement reports. Change the case statement code as outlined in the above coding guidelines. Whenever the synthesis tool reports that the case statement is not parallel. That is, whenever the synthesis tool reports no for the parallel case. These are the guidelines for coding priority encoders. What are the limitations of using tri-state logic? The presence of internal tri-state logic is a critical consideration for power-sensitive products. Normally, a multiplexer should be used in place of tri-state logic. However, if the tri-state logic remains in the RTL, it is not an error for compilation. Synthesis tools sometimes warn the users. The linting tools also detect this condition and report this to the user. Next question. What is the effect of specifying a function without a range? If a range is not specified, Verilog will assume a 1-bit return value. If a multi-bit return value was calculated in the function, only the least significant bit is returned. Thank you.